Hello, in this unit we will learn about elements and how they affect us and this universe. Before all this, we didn't know what elements were. We just thought the world was made of small little circles. But with enough science, we were able to find out what elements were actually made out of. We first found this out through J.J. Thomson. J.J. Thomson actually was the one who found out that elements were actually made out of a couple particles. He found one of the particles. Thomson found this one particle through the plum pudding model. Thomson used the plum pudding model to prove that there were both negative and positive charges in an atom. Thomson did help in the discovery of the electron. Rutherford helped in the discovery of the nucleus. Rutherford was the one that helped create a more wider and broader view of the atom. Rutherford was able to create this wider and broader view through his experiment. Rutherford's experiment was to see if J.J. Thomson's plum pudding model was correct. J.J. Thomson's plum pudding model was that there were several negative and several positive charges in one atom, and that they connected to each other just to make the entire atom. When Rutherford actually tried to experiment with this, he found something different. He used a gold foil and he shot several particles over to the gold foil. He found out that some of these particles went through, but some shot back, and some were deflected several different directions. He came to the conclusion that there was something that was with the same energy that the particles were made of, was making all these particles go different directions. He found out that the gold foil had a nucleus, and the nucleus had protons. These protons were positive charged, and they were able to deflect the other positive charged nucleuses away from the gold foil. This is my own little Rutherford experiment. Here we go. 1, 2, 3. Imagine one actually going through, and then the two other bouncing away. It's a similar thing. One solid is making sure that these little pellets are not going through. Rutherford and J.J. Thomson, we now know that atoms are made out of three particles: protons, neutrons, and electrons. Protons are positively charged particles that are found in a nucleus. Electrons are negatively charged particles that surround the nucleus, and neutrons have no charge but are still in the nucleus. Rutherford and Thomson did help with the discovery of the atom, but it was Dalton's theory that helped with trying to find out what an atom was made of and how an atom can change. Dalton's theory was that you could not create or destroy atoms because they are made of matter, but you can change atoms through chemical reactions. These changes can result into creating compounds. Dalton also thought that compounds could be created by two or more atoms. Dalton also came up with the law of constant composition. This means that any substance has the same amount of elements and the same amount of compounds inside the substance. This also means that each compound has the same proportion of elements in each compound. So, for example, H2O will always have two hydrogens and one oxygen. Dalton was correct about atoms not being able to be created or destroyed. And he was also correct that atoms could change through chemical reactions. I chose one element out of all the periodic table to to focus on. This element is sodium. But sodium is a soft silvery metal that can easily be cut. Sodium is part of the family group of the alkali metals. Alkali metals are metals that are shiny, soft, and react highly to standard temperature. Family groups are elements on the periodic table that have similar properties. Sodium has a long history. It started during the Silk Road, where salt was actually sold for a lot of money. Over time, people started to wonder what made the salt. Around the 1800s, scientists started to study with sodium, and around 1860, two men named Kirchhoff and Bunsen lit some sodium on fire and found out a chemical reaction. Because sodium is one of the alkali metals, it has a chemical reaction when it touches water. It actually combusts when it touches water. Sodium has the atomic mass of 11, the elemental symbol of Na, and the atomic number of 22. The atomic mass is what tells us how many protons and electrons there are. The elemental symbol tells us what the element is called, and the atomic number tells us how many neutrons and protons are in the nucleus. Another way of showing the atomic mass, the atomic number, and the elemental symbol is using A, Z, and X. A being the atomic number, Z being the elemental symbol, and X being the atomic mass. There are many forms of sodium, and one is an isotope that has the atomic number 23. This means that there are 11 protons and 12 neutrons. An isotope is when there are more or less neutrons in an atom. Chemical formulas help us find out what elements are in compounds and what substances contain these elements and compounds. For example, this substance is salt. Everyone knows what salt is. But salt actually contains sodium and chlorine. These two elements actually combine with each other to make sodium chloride, which is salt. Sodium is actually found in the Earth's crust and is also found in a lot of the food that we eat. A chemical formula helps you find out the proportion of elements that are in compounds. Compounds are two or more elements that are put together to make one single substance. For example, NaCl is the compound for salt, Na being sodium and Cl being chloride. 7 different compounds on the periodic table that are really most known. These are called diatomics. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Ions are elements that have a more positive charge or more negative charge. This is because an element will either give up electrons, which will give it a positive charge, or will gain electrons, which will gain a more negative charge. A positive charged ion is called a cation, and a negative charged ion is called an anion. On the periodic table, it shows that all metals are cations and all non-metals are anions. The anions are all on the right side of the periodic table, and all the cations are on the left side of the periodic table. It takes one cation and one anion to create an ionic compound. The picture up top shows the two elements, sodium and chlorine. As you can see, sodium is giving away electron and giving it to chlorine. This is because so that each element can have an opposite charge so that they can attract and create a compound. Overall, sodium is a good metal to study. I found out that sodium is actually all around us, even in the places that we don't expect it. Sodium is actually found in a lot of minerals and is found in many of the utensils that we use today. It is a helpful element and it's what makes many substances around this world.